Good morning, all you cool cats and kittens. Welcome to another edition of Science TV with Mr. C. Today, we are going to further your knowledge on the periodic table and how atoms bond with each other. So let's go ahead and start with checking out slides 3 to 15 on this link here. So here we have lesson 1, atoms bonding in the periodic table. And our learning objective is explain what determines an element's chemistry. Normally, we would do this kind of activity on a concept map, but today we are going to just go through it. So, we've seen that atoms don't always exist as separate detached particles. In fact, they rarely do. They interact with each other. Sometimes they react with each other. Sometimes react with other elements. So, for instance, sometimes, like in our atmosphere, oxygen will react with oxygen, and we get the O2 we breathe. And then sometimes oxygen will react with hydrogen, and it gives us water. These unions are accomplished by sharing electrons. There's a chemical reaction that bonds them together. It's a simple force of attraction. We're talking about these electrons that are being shared, gained, lost. These are the valence electrons we talked about last chapter. They have the highest energy levels of all of these atoms. They're what's involved with the chemical bonding. Now, as these atoms are connecting with each other, it can be 2 atoms, it can be 3 atoms, it can be 12 atoms. These things are called molecules. Anytime there are 2 or more atoms bonded together, it's called a molecule. Now, every element has valence electrons. Each element has a specific number based upon where it is positioned in the periodic table. We've spoke before about how group 1, everything in group 1, from helium down to francium, all have 1 valence electron. Group 2 all have 2 valence electrons. Periodic table gets a little wonky there for a little bit between 3 and 12. Those are our transition metals. They can vary between 2 and 3 and 1 valence electrons until we get to group 13, and it starts following the pattern again. Group 13 has 3 valence electrons. Group 14 has 4. Group 15 has 5. Group 16 has 6. 17 has 7. And group 18 has 8. Here we have nitrogen. See here, its letter N is its chemical symbol. It is in group 15. It has an atomic number of 7, which means it has 7 electrons. But since it's in group 15, it only has 5 valence electrons. When we're doing an electron dot diagram, sometimes called a Lewis dot diagram, we have 4 spots in which we can put the electrons. Top, bottom, left, or right. Now when we're filling these out, it's important that we have 1 valence electron in every shell until all 4 are filled. Then we can put a second one in the box. So here's an example. We have 5 valence electrons for nitrogen. First from the top, next to the left, second to the right, or third on the right, fourth on the bottom. Now we've got 1 in every shell there. We have 1 more put over. And it doesn't matter which order you put them in, as long as you do it 1 in all 4 of those slots before you have 2 in a slot. Easy enough. So this is an electron dot diagram for the element nitrogen. Now, atoms bond because they tend to be more stable when they have 8 outer shell electrons. This force of attraction between those electrons would actually hold those atoms together and make those molecules stable. Now, depending on how many valence electrons an atom has, it will determine whether or not these elements will lose or gain elements. Noble gases on the far right of our periodic table in group 18 already have 8 valence electrons, except for helium, which only has 2. They all have full outer shell electrons. They're very stable. They typically don't bond well with other elements. So noble gases are kind of an exception to these rules that we're talking about because they don't bond anything. They're already 8, so they don't need any more. Now, we talked about metals once upon a time earlier in the semester, and we said one of the properties of a metal is they will lose electrons. And one of the reasons why they do this is if you look on the periodic table, there are no metals that have more than 4 valence electrons. In fact, most of them have 3 or less. For these atoms to be stable, remember they're trying to get to 8. Now, if you only have 3 valence electrons, to get to 8, you'd have to add 5. What these metals are able to do, they're able to lose electrons to go back an energy level. So, for instance, we have sodium, has 11 electrons total, and only one valence electron. Now, it could gain 7 to become stable, but it would be much easier for it to just lose 1 and drop down to the previous energy group and give it a full 8. So metals tend to lose their electrons when they are bonding with other atoms. Nonmetals, the opposite. They will usually have 4 or more valence electrons. Chlorine has 7 valence electrons. It's a halogen. In the halogen family, it has 7 valence electrons. For it to get to 8, it's easier for it to just gain an electron. What it often does, and this is a good food additive for us, is salt. It will gain the electron that sodium lost to get to 8. When it gains an electron, it has a negative charge because it has more electrons than it does protons. It's attracted to positively charged atoms, which sodium would be positively charged because it lost an electron, giving it a positive charge. So nonmetals will gain electrons, metals will lose them. Now we've said before that metalloids share properties of both metals and nonmetals, so they can gain electrons, they can share electrons, or they can lose. They can kind of do it all. Hydrogen is one of these special cases here, along with helium. Hydrogen is in group 1 because it only has 1 valence electron. It's considered a nonmetal though because it has all the other properties. It doesn't lose electrons. It will only gain or share. It is happy at 2, just like helium is, so we want to remember that in the future. And there's metalloids there. So that is it for the slideshow presentation. I know you guys would probably rather have done a concept map. I guess if you want to, you can, just for old time's sake. That's up to you, but I'm not going to require it this time. Back to our calendar we go. After having this information for this, we're going to move on to electron dot diagrams. We're going to practice kind of what we just went over. When you click on this electron dot diagram, it's going to show you, it's going to ask you to create some electron dot diagrams for here. Okay, for sodium, carbon, silicon, phosphorus, sulfur, lead, argon, chlorine, calcium. Those elements there. So now in the directions here, it tells you if you want to hand draw them, you can hand draw them. If you want to take a picture of that and then upload the image for your assessment, that's fine. If you want to make a document with them, one thing you could do is probably a Google Sheets or Google Doc and manipulate it that way, adding some pictures to it. However you want to do it, that's fine. We've already went over nitrogen. We'll go over another one here too. Let's do chlorine. I'll show you how to do chlorine. I'm going to do it through Microsoft Paint. Here we are in Microsoft Paint. We're going to do chlorine. So what we're going to do is we're going to use a text box. Draw it right here, and the chemical symbol for chlorine is, hopefully you remember, is Cl. Cl right there. We're going to tighten this box up a little bit. Chlorine is a halogen. So it means it has 7 valence electrons. So we're going to put 7 valence electrons for this guy. Use this marker here, get a little bit of thickness. 7. So we're going to put 7 dots for our electron dot diagram. We'll start at the top here. 1. I'll go 2, 3, 4. Now we have 1 in all 4 of those slots. So now we can start putting 2. 2 for that. Now we have 7. So notice that these valence electrons, they're only going to have 2 in a slot. This one's full. This is full. This is full. This one is short by 1. Remember we said that chlorine wants to gain an electron to become stable. So it is missing this right here. And it's going to do anything it can to get that electron, and oftentimes it takes it from chlorine. So that is kind of an example of how you would do the remaining elements on that table. Find out where they're at the periodic table, determine how many valence electrons they have, and draw a little valence electron, something like this. Doesn't have to be anything amazing. And then again, when you've done all these, make sure you take a picture of it, submit it. If you need to share it, and turn it into the electron dot diagrams place here. Finally, on our calendar, we have the salt on the fries activity. Salt on the fries. Bring that up. We know salt's made up of sodium and chlorine. We've seen sodium reacts with water. Chlorine is a poison. When they come together, this is chemical bonding. You are going to read through this. You're going to go to the chemical bonding, read the first 2 paragraphs, look at some pictures of sodium and chlorine forming salt, and answer the workspace questions. For these answers, you're going to open up a text box with a submission. You're going to type number 1, write down the answer. Okay? Pretty easy, 5 questions, shouldn't take very long. On the calendar, there's also the chatter doc if you want to ask questions there, or you can shoot me emails. Any way you choose works for me. Thanks for listening, and have a great day. Thanks.